In this question, we want to maximize the function r equals 2x plus 3y subject to the following constraints. So because of the first two constraints, we know that we're going to be stuck in the first quadrant. Negative 2x minus y greater than or equal to negative 10. If we rearrange this, add 2x to both sides, we get negative y greater than or equal to 2x minus 10. And now we need to divide by a negative 1 because we need to solve in terms of y. And if I divide by negative 1, remember, the sign flips, so we get y is less than or equal to negative 2x plus 10. So that's the constraint. Now here's a quick recap as to why that is. Why do we need to flip the signs? Well, if negative 5 is less than negative 4, you might want to spend a second to confirm that. If I divide both sides by negative 1, really ultimately what I'm doing is just removing the negative signs in this case. Well, but now 5 is not less than 4. So if I remove negatives, then the polarity switches around. In other words, from 0, going this way is lesser, but going this way is higher, and so that's why we need to do it. This guy right here, this constraint, will reduce to x greater than or equal to 3. Because we're subtracting 3 from both sides. So that means that if I come over here and I graph this, the first thing I want to do is want to check my window, make sure that I'm going to get a good window, so I'm from 0 to 10 on the x, 0 to 20 on the y, and I'm going to come over to graph it. There's my y less than or equal to negative 2x plus 10, so that's going to include everything below the graph. X greater than or equal to 3, well right now we can't really graph a vertical line, but x greater than or equal to 3 means we want something in this direction of the vertical line at input of 3. So what we're going to basically have 3 points. We're going to have one at 3, 0, because we can't go negative. We're going to have one at 3, comma, whatever this point is, and we're going to have one at looks like 1, 2, 3, 4, 5-ish, comma 0. Okay, so what we're going to do is I'm just going to replicate this here, and I'm going to say, okay, I know that at x equals 3, that's the area I'm going to draw. I'm going to shade this way. Now, here I'm going to shade below, so the only point at which my shading would overlap would be this region here. So I have 3 corner points, there, and there. I know that this corner point is 3, comma 0. I'm going to sketch this over here and make it a little bit more clear. So this point right here is 3, comma 0. I don't exactly know what this is yet, and I don't exactly know what this is yet, but what I'm going to do is find out. That is, if I put in an input of 3, I should be able to figure out what that point is. Well, if I put in 3 for x, I'm going to do it more quickly here. I'm going to calculate value and input x equals 3, and it's going to tell me that on this line, negative 2x plus 10, with an input of 3, you get an output of 4. So this is 3, comma 4. Now I want to know where the horizontal intercept is. That's my other point over here. So what I'm going to do is I'm going to plot the line y equals 0. That way I have a graph of 2 lines, and I need to find the intersection point between them. You can't really see the line because it's hidden over the horizontal axis. So I'm going to do intersect. My first curve is, sure, y1 is negative 2x plus 10, enter. It automatically jumps to y2 equaling the 0 horizontal line. And now it wants me to guess, that's pretty close to where I think the point is. And it tells me that the intersection does in fact occur at 5, comma 0. We got 3 corner points. We need to test them in our function. So we're going to do point and then value. This is the objective value. Objective function value. So I have 3, 0. Well, if I put in 3 for x and 0 for y, I get 6 plus 0 is 6. If I put in 3, comma 4, then I get 3 times 3, or 2 times 3 is 6, plus 3 times 4 is 12. 12 plus 6 is 18, so that's bigger. And then if I put in 5, 0, I get 2 times 5 is 10, plus 0 is 10. And I find out that this point right here, 3, 4, produces my largest objective function value. Therefore, this is the point that maximizes the objective function. So 3, 4 maximizes objective function.